Triangle ABC with vertices A13, B52, and C21, and its image after the reflection described. Part A. In line N, x equals -1. First, you want to graph triangle ABC with vertices A13, B52, and C21. Then graph line N along x equals -1. Point A is 2 units right of line N, so its image, A', is 2 units left of line N, at -3, 3. Also, point B is 6 units right of line N, so its image, B', is 6 units left of line N, at -7, 2. And point C is 3 units right of line N, so its image, C', is 3 units left of line N, at -4, 1. To complete the graph of the image, draw line segments connecting the vertices. Part B. In line M, y equals 3. First, you want to graph triangle ABC with vertices A13, B52, and C21. Then graph line M along y equals 3. Because point A is on line M, you know that A equals A'. So A' is also on line M at 1, 3. Also, point B is 1 unit below line M, so its image A' is 1 unit above line M at 5, 4. And point C is 2 units below line M, so its image, C', is 2 units above line M, at 2, 5. To complete the graph of the image, draw line segments connecting the vertices. Graph triangle the vertices. Graph segment AB with endpoints A3, -1 and B3, 2, and its image after a reflection in the line y equals x. First, graph segment AB with endpoints A3, -1 and B3, 2. Then graph the line y equals x. The slope of y equals x is 1. The segment from A to its image, segment A', is perpendicular to the line of reflection y equals x. So the slope of segment A' will be -1, because the product of the slopes of perpendicular lines is -1, and 1 times -1 equals -1. From A, move 2 units left and 2 units up to y equals x. From that point, move 2 units left and 2 units up to locate A' at -1, 3. The segment from B to its image, segment B', is also perpendicular to the line of reflection y equals x. So the slope of segment B', will also be -1. From B, move 5/10 unit left and 5/10 unit up to y equals x. From that point, move 5/10 unit left and 5/10 unit up to locate B' at 2, 3. To complete the graph of the image, draw a line segment connecting A' and B'. Graph and AB with endpoints A3, -1 and B3, 2, and its image after a reflection in the line y equals -x. First, graph segment AB with endpoints A3, -1 and B3, 2. Then graph the line y equals -x. To find the image of segment AB after a reflection in the line y equals -x, first find the image of each endpoint after a reflection in the line y equals -x. If the point AB is reflected in the line y equals -x, then its image is the point -b, -a. The coordinates of A are 3, -1. So here 3 is A and -1 is B. The negative of -1 is +1, and the negative of 3 is -3. So A3, -1 maps to A prime 1, -3. Similarly, B3, 2 maps to B prime -2, -3. To complete the graph of the image, draw a line segment connecting A prime and B prime. Graph segment. Triangle ABC with vertices A3, 2, B6, 3, and C7, 1, and its image after the glide reflection. A translation such that the point xy maps to the point xy minus 6, followed by a reflection in the y-axis. First, you want to graph triangle ABC with vertices A3, 2, B6, 3, and C7, 1. Next, you want to translate triangle ABC 6 units down. This translation maps the point xy to the point xy minus 6. 2 minus 6 is -4. So point A32 maps to point A prime 3, -4. Similarly, point B63 maps to point B prime 6, -3. And point C71 maps to point C prime 7, -5. To complete the graph of A prime, B prime, C prime, draw line segments connecting the vertices. Now you want to reflect triangle A prime, B prime, C prime in the y-axis. A reflection in the y-axis maps the point xy to the point -xy. The negative of 3 is -3, so point A prime 3, -4 maps to point A double prime -3, -4. Similarly, point B prime 6, -3 maps to point B double prime -6, -3. And point C prime 7, -5 maps to point C double prime -7, -5. To complete the graph of triangle A double prime, B double prime, C double prime, draw line segments connecting the vertices. So triangle A double prime, B double prime, C double prime is the image of triangle ABC after the given glide reflection. Glide reflection. How many lines of symmetry does the triangle have? One line of symmetry for the triangle is the vertical line that passes through the vertex and the midpoint of the base of the triangle. Notice that a reflection in this line maps the left half of the triangle to the right half of the triangle, and the right half of the triangle to the left half of the triangle. Because the triangle is equilateral, it has 3 congruent angles and 3 congruent sides. This means there are 3 such lines of symmetry. So there are 3 lines of symmetry. How many lines of You are going to the music store. Your friend is going to buy craft supplies. Where should you park to minimize the distance you both will walk? Let C be in front of the arts and crafts store on the same line as segment AB. First reflect C in line M to obtain C'. Then draw segment AC'. Label the intersection of segment AC' and M as D. Notice that AC' is the shortest distance between A and C'. Also notice that the distance between C and D is equal to the distance between C' and D. The distance between A and C' is equal to the distance between A and D plus the distance between C' and D. Because the distance between C' and D is equal to the distance between C and D, the distance between A and C' is equal to the distance between A and D plus the distance between C and D. Because AC' is the shortest distance between A and C', and because CD equals C'D, park at point D to minimize the distance AD plus CD you both have to walk. You are going to have to